Hello, welcome back to the second and last part of lesson 5.3. We are going to jump right back in where we left off on problem number 53 and 57. They gave us the picture. So if you look it up, page 50 or page 437 on number 53, they gave us this angle here and then the side too. So because this is a 45 degree and the sum of the angles have to equal 180, and this is the right angle, we know that this also must be a 45 degree. So we just found the other angle. It's asking us to find all the angles and the sides. So we know that this is an isosceles triangle, which means that if this side is 2, then the opposing side is 2. And then the hypotenuse, we learned that earlier in the lesson that the hypotenuse is always 2 times the square root of the side, but we can find that by doing C is going to equal the square root of 2 squared plus 2 squared. So the square root of 4 plus 4, which is the square root of 8, which is the square root of 4 times the square root of 2, which is 2 times the square root of 2. So we know the hypotenuse is 2 times the square root of 2. Okay, so that's one triangle that we should be getting familiar with. 57 is also a picture asking us to find the other angle here that is complementary to 15 degrees. So that would be 90 minus 15 is 75 degrees. So this one is 75. And then we know it's a 30, 60, 90 triangle and the hypotenuse is 12. So we could use find this side here opposite of our angle. This is our opposite side. So we know that sine is, let's give ourselves some room. Sine is opposite over hypotenuse. So we know the sine of 15 degrees is going to be equal to the opposite side over 12. So we're going to call the opposite side x. So x is going to equal 12 times the sine of 15 degrees. So let's get out our calculator here. Making sure, because we're using degrees, make sure our mode is in degree mode. That's critical. Yep, it is. Okay. So we can say 12 times the sine of 15 is 3.1058 is this side right here. 3.1058. And then we can find cosine. We can find the other side by doing a couple of different things. We can use our Pythagorean theorem, because we know side B is the square root of C squared minus A squared. And so B is equal to the square root of 12 squared minus A is 3.1058 squared. Because 12 is our hypotenuse. So we can say square root of 12 squared minus 3.1058 squared. And that comes out to be approximately 11.5911. 11.5911. Awesome. 61 is the next one. It's asking us to find the measure of the acute angle. So find the acute angle of theta, who they gave us sine and cosine. So they gave us a cosine of is equal to square root of 2 over 2. So we know the adjacent side to the angle is square root of 2. And we know the side or the hypotenuse is 2. Okay, so we want to find the acute angle. Find the measure of the acute angle. Okay, so we know this cosine is this. So we're just finding the cosine that is square root of 2 over 2. And if we go to our rules that we have written down, we know that cosine is the square root of 2 over 2 at a 45-degree angle of pi over 4. So it's a 45 degrees. So that angle is 45 degrees. Okay, let's go to number 69. Sorry about that. So I'd like you to turn to number 69. And I'm just going to show you here. Do a couple application problems. 69 here says, from the basket of a hot air balloon 100 feet above the ground, the angle of depression of a point A on the ground is 10.5 degrees. What is the distance from point A to the basket of the balloon? Let's draw this, how it's explaining. From the basket of a hot air balloon. So we have the basket of the hot air balloon, right? This is our hot air balloon. Okay, here's the ground. It says from the basket of a hot air balloon 100 feet above the ground. So this is 100 feet above the ground. The angle of depression. So the angle of depression is this angle. I didn't draw that very straight. This angle here is the angle of depression, which is 10.5 degrees. So we know from algebra that this angle and this angle here are the same. So this is also 10.5 degrees because these angles make a 90 degree to the ground. And so these add up to make 180. Okay, so 10.5 degrees. What is the distance from point A to the basket of the balloon? Okay, the angle of depression. So this is point A right here. This is point A. They want to know what is the distance from point A to the basket of the balloon? So this distance right here, they want to know. So using that, we're trying to find the hypotenuse. So the hypotenuse, we could use sine or cosine, but sine is opposite. So sine is opposite over hypotenuse. So right now we know the sine of 10.5 degrees is equal to 100 over X. We're going to call this X for the hypotenuse here. So we can multiply both sides by X. And then divide by the sine. So X equals 100 divided by the sine of 10.5 degrees. So 100, show you on the screen. 100 divided by the sine of 10.5 degrees. Got to make sure your mode is in degrees. So 548.7 feet, I believe. 548.74 feet. Let's make sure it's in feet. Make sure you have the right, feet units. So drawing a picture should definitely help you. The last problem I had for this lesson is 81, which is all. So 81 says, a security camera is mounted on the wall at a height of 10 feet. At what angle of depression should the camera be set? If the camera is to be pointed at the door 50 feet from the point on the floor directly under the camera. Let's try to draw a picture. Okay. So we're going to draw the camera. There's the camera scene. It's 10 feet on the wall at a height of 10 feet. So this is 10 feet. At what angle of depression but remember that also equals theta here. Okay, so at what angle of depression should the camera be set? If the camera is to be pointed at the door, so this is our door here. That's the door. At the door, 50 feet from the point on the floor, directly under the camera. So we're thinking this is 50 feet. If the camera is to be pointed at a door, 50 feet from the point of the floor directly under the camera. So I think this is the 50 feet. Okay. So the angle of the opposite over the adjacent, opposite over adjacent would be these two sides, is the tangent. And so we know the tangent of that angle is ten over 50, which is 1/5. So we're going to use the inverse tangent. I don't recall them using this in the lesson, but we could have used it with number 61 here as well. Because when you don't know the angle, but you know the ratio, you can use the inverse. So I'm going to go back to 61 for just a minute if you can get out your 61. So notice your keys are sine, cosine, tangent, and then you have inverse sine, inverse cosine, inverse tangent, tangent to the -1. So inverse, let's just write this here. Cosine -1 of the square root of 2 over 2 gives me that angle in degrees. But you have to have your calculator in degree mode. So I'm going to show you that mine is in degree mode. Mode is in degree. Oops. Mode is in degrees. Okay. Okay. So I'm going to do my second and my cosine. See, it's inverse cosine. Then I'm going to put the square root of 2 divided by 2, and it'll give me 45 degrees. So we knew it because in our table, it's one of the ratios that we have in common that we've been using. But if you didn't know that, you could use your inverse cosine. So on number 81, we can also do that because we want to know the tangent, which is we have the value opposite and we have the length adjacent. So we know that ratio opposite over adjacent is 10 over 50, 1 over 5. So we can do the inverse tangent of 1/5 to get theta in degrees. So I'm going to look this up. And the calculator. Okay, so I'm going to do second and tangent. So it's inverse tangent of 1 divided by 5 will give me 11.3 degrees. Make sure I had that correct from what I had before. So 11.3 degrees. So the extra ones that I assigned for you are number 70, which is another navigation similar to 69 that we did. And then also number 82, which is to estimate the height of the object case to 20 feet from the statue and measure the angle of elevation to the top of the statue to be 70. What is the height? So you're going to know the angle on 82. So they should be fairly similar to the ones that we did. Catch me back for lesson 8.4.